Hello students, this video lecture will cover section 9.2, Reflections. Our learning goal for this lesson is to be able to find reflection images of figures. The key concept of this lesson is reflection across a line. So if we're going to reflect something across line R, which is called the line of reflection, this is going to be a transformation that holds two properties. In the event that a point is actually on the line of reflection, then the image of that point is that point itself. But for every point that is not on the line, then R is the perpendicular bisector of that point and its image. So we can see here this is line R. Point B is not on line R. So it's reflected an equal distance across the line, and it's at a 90-degree angle. As with what we studied about translations, a reflection across a line is also an isometry, meaning that it maintains congruence. So our first question asks us to reflect a point across the line. So it says, what are the coordinates of the reflection of 3, 4 reflected over the line y equals 1? So the first thing that I want to do here is I want to actually draw y equals 1. So if you recall, y equals 1 is going to be a horizontal line. So we have the point 0, 1, we have the point 2, 1, we have the point 5, 1, so on and so forth. So we're going to connect those with a line. So we have this point 3, 4, and we're trying to reflect it across this line. So what we're going to do is we're going to draw the line. So we have this point 3, 4. We're going to try and reflect it across y equals 1. So we're going to draw the perpendicular line. So here, we're going towards the line that we are looking. So here we're going to take this point 3, 4 and we're going to draw the ray that goes directly towards y equals 1 at a 90-degree angle. We're going to count how many squares it takes to actually get to the line y equals 1. So we go 1, 2, 3 squares to get there. So then we go 1, 2, 3 squares past. And this is the point of reflection that we're looking for. So this point has coordinates 3, negative 2. The second part of this question asks, well, what would happen if we reflected across x? The second part of this question asks us, what would happen if we reflected across x equals negative 1 instead? So let's go ahead and draw x equals negative 1. So x equals negative 1 is going to be a vertical line, 1 to the left of the y-axis. So similarly, we're going to draw the ray that takes us from that point directly across the line that we're looking to use as the reflection. We're going to count how many squares. So it's 1, 2, 3, 4 squares to get to the line. So 1, 2, 3, 4 squares past. and we're going to draw that point. So the coordinates of this point now are 1, 2, 3, 4, 5 to the left. So we have -5, and we're still up 4. So our second question asks us to graph a reflection image. So we're supposed to graph 3 points. So we have -3, So we have 3 points here. We have -3, 4, so we're left 3, up 4. So we have a point right there. We have the point at 0, 1, so this is a location. And we have a point at 4, 2, so that's our final location. So let's connect these to get our triangle. So here we have triangle ABC. So then we're going to take this and we're going to reflect it across the y-axis. So all of these points are going to be reflected across the y-axis, which is this right here. So for instance, this first point, since it's on the y-axis, it's not going to move at all. So we're going to take this location and we're going to mark it because it's going to be exactly the same. So those 2 points are going to overlap. Now, just like we did on the previous slide, we're going to take this point and we're going to go directly towards the y-axis and past it. So 1, 2, 3 gets us to the y-axis. 1, 2, 3 past it gets us the point that we're looking for. And the same thing with this location. We go 1, 2, 3, 4 to get to the y-axis, and then 1, 2, 3, 4 past it. And if we connect these 3 locations, that'll get us the triangle that we're looking for. And so finally, we're asked what the image of triangle ABC reflected across the x-axis is. Let's go ahead and take all of these points and take them to the x-axis. So we have triangle ABC was our red triangle. So we're going to go towards the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. So we can see in this case it took 4 to get to the x-axis. So 4 past it. This point's really close to the x-axis, so just 1 gets us there, and then so 1 past. And finally, this final point, it takes 2 to get to the x-axis, so 2 past us will get us the location that we're looking for. So then by connecting these locations, we get the triangle that we're looking for again. So here we have triangle ABC reflected across both the y and x axis. So problem 3 is a question about minimizing distance. It says that beginning from a point on Summit Trail, a hiking club will build a trail to the overlook and a trail to Balance Rock. Working under a tight budget, the club members want to minimize the total length So our third question is about minimizing distance. It says that beginning from a point on Summit Trail, a hiking club will build a trail to the overlook and a trail to Balance Rock. Working under a tight budget, the club members want to minimize the total length of the two trails. How can we find a point on Summit Trail where the two new trails should start? We want to assume that the two trails will be straight and cover similar terrain. So what exactly is this question asking? What it's asking is we're going to try to find some point on Summit Trail where if we drew a line to overlook and we drew a line to Balance Rock, these two lines combined are as short as possible. So we can see that there are lots of locations that we could potentially start from, and they'll yield different lengths combined. Now what's kind of interesting is most of you realize that the shortest distance between 2 points is a straight line, assuming a flat surface. So when given a question like this is actually a reflection type question. What we want to do is take one of these 2 points and reflect them across Summit Trail. Okay, so the first thing that I'm going to do here is extend Summit Trail so that I can work with it a little bit easier. Then I'm going to take my compass and I'm going to place it at overlook. And I'm actually going to reflect overlook perpendicularly across the line. So I'm going to use a method that we learned way back in chapter 1. So I'm going to draw an arc. So I'm going to draw an arc that touches this extension of Summit Trail in 2 spots. Then I'm going to take my compass, I'm going to open it more than halfway, and I'm going to draw 2 half circles, one from each location where that first arc touched the dotted line. And that's going to give me the 2 points that I need to construct the perpendicular bisector. And that's going to give me the 2 points that I need to construct the perpendicular line. So you can see this red line is perpendicular to Summit Trail and it contains overlook. So now I'm going to take my compass and I'm going to place it on the intersection of the new red line and Summit Trail. And I'm going to measure off the distance to Overlook. And I'm going to reflect Overlook across this line. So this is what I would like to call Overlook if it was on the other side of Summit Trail. So if we add a couple points in here, if this is our reflection line and this is Overlook, then this would be something like Overlook Prime. So now let's connect Overlook Prime with Balance Rock. You'll notice that now that Overlook is on the other side of Summit Trail, since Overlook is on the other side of Summit Trail, we have this intersection point with the line of reflection. That is actually the intersection that we're looking for. So by constructing this trail to Overlook Prime, we get the shortest distance between these 2 points, which is this straight line. Now since this is a reflection, you can see that what we're actually constructing here is 2 congruent triangles. We have 2 right triangles. These lines are going to be equal by the rules of reflection. We have that the distance from O prime to the line of reflection has to be the same as the line of reflection to Overlook. And then we have this reflexive side in the middle. So by side angle side and CP/CTC, we know that these 2 distances are the same. So the reflection of this piece of the line to this side gives us the continuation as if it was a straight line to begin with. And so that'll be the shortest distance to find that point on Summit Trail. And that concludes this video lecture on section 9.2. Hopefully you understand how to find reflection images of figures now. And I'll see you guys soon.